Hey everyone, we're going to take a look at f of x is equal to x squared minus 4 quantity divided by x. Now, since there's a higher exponent squared in the numerator than the denominator, we don't have a horizontal asymptote. Instead, we have what's called a slant asymptote. And if we take x and we divide it into x squared minus 4, x divides into x squared plus 0x minus 4x goes into there, so that's x squared. Bring down the 0 plus 0, bring down the minus 4, oh no, remainder of minus 4. It turns into x, what, minus 4 over x. We get rid of that, and instead we look at just this. We kick off the remainder. Y equals x, that's our slant asymptote. That means as x goes to infinity, f of x goes to x. As x goes to negative infinity, f of x goes to x. So now that we've got this long-term behavior out of the way, we've described the slant asymptote, let's go ahead and let's determine the domain, the vertical asymptotes, and everything else for this function. So I'm looking at the domain of it, and x cannot be 0, which means we're going to have a vertical asymptote at x equals 0, right? Because it doesn't cancel out with anything in the numerator. We covered slant asymptote instead of horizontal asymptote. Let's look here at the numerator. X squared minus 4 equals 0. Let's look for some zeros. I get x is equal to plus or minus 2. Those are the zeros. And I guess maybe we just need some points. But you know what, I'm going to pull up my axes here and we'll plot those points later. Let's instead draw our slant asymptote. Here's the slant asymptote. I'm going to have to match that behavior long term, right? The zeros are at plus 2 and minus 2. There's a vertical asymptote at 0. Okay, so we can see how the axes have been, the plane rather, has been broken up into 1, 2, 3, 4 pieces by these two asymptotes, these two blue asymptotes. So in this region right here, I get the feeling that we're going to have something like this, call it. We're going to have something that kind of fills in here, comes through the 0, then matches and goes vertically, and the same thing here is going to come through and vaguely go through that. I could confirm my feelings by going and graphing, or rather finding, f of 1 is equal to 1 minus 4 over 1, negative 3. F of negative 1 is equal to 1 minus 4 over negative 1, which would be what, a positive 3? So negative 1 is at 3, 1 is at negative 3. Look at that. Maybe we could find f of 3. That looks like that'd be useful. So that's 9 minus 4 over 3. That's 5/3. So that's almost 2. 1 and 2/3, right? So 3 is 1 and 2/3. That's about right there. Hey, that's like right where I had it. That's complete coincidence. F of negative 3 is again going to be 9 minus 4 over, hey, wait a minute, you know what? F of negative x, are you, let's see here, x squared minus 4 over negative x. Hey, look at that. F of negative x, you're equal to negative f of x. This function's odd. So that means this point, this negative 3 mirrors there. This 3 comes down here, mirrors it that way. Great. You know what? Let's go ahead. Let's draw this in. let's draw in. This is coming down. This is going to come up. And these slant asymptote ones are never super steep and super sharp. They have a lot more gradual curve than the other ones. But I think we did it. We got the slant asymptote. We got the graph. We've got our function. Great job, everyone. See you next time.